Hi dear students, welcome to the session of Mathematics of class 9. Today let's get into the chapter Surface Areas and Volumes with a new exercise, exercise number 13.8. So dear students, in this exercise, the final exercise of this chapter, exercise number 13.8. Actually here we are going to deal with some metallic spheres and hemispheres. So let us recollect what we have studied about spheres and hemispheres. Sphere, you know, it's spherical in shape. It's only having a single surface, and that's what we mean by the surface area. And the surface area of a sphere can be obtained by the equation 4 pi r square. And the volume of the sphere can be calculated by the equation 4 by 3 pi r cube. Half of the sphere is what we call the hemisphere. So half of the volume of the sphere will be that of the volume of a hemisphere. That means 2 by 3 pi r cube will be the volume of a hemisphere. And the Csa of the hemisphere will be half of that of the sphere. That means talking about a sphere, it was 4 pi r square. So what about here? It will be 2 pi r square. Then the total surface area of a hemisphere will be 3 pi r square. So these are the main equations which we are going to deal with in this exercise. So here goes the very first question from you, exercise number 13.8, the very first question before you. The diameter of a metallic ball is 4.2 centimeter. So here it is very clearly mentioned that it is the diameter. It's the diameter, not the radius. So from this one, what you have to write, diameter of the metallic sphere or the metallic ball is 4.2 centimeter, means the radius will be half of this one. It means the radius is 2.1 centimeter. Clear? That much you have to bring into your mind. Now, the next thing, what is given? What is the mass of the ball? You have to find the mass of the ball if the density of the metal is 8.9 gram per centimeter cube. Oh, here it's a typical type of question. The density is given. The density of the material, of the density of the ball is given. You have to find the weight. That means you have to find the mass. So what is it related with mass, volume and density? When studying physics, there we studied that mass is equal to volume into density. Volume multiplied by density is what we call the mass. So from this one, density is already given. So what else should be found? Volume. Because volume into density is what mass is. So as the density is already mentioned as 8.9 gram per centimeter cube, the only thing which you have to find is the volume of the sphere. So now tell me, how will you find the volume of a sphere? 4 by 3 pi r cube. That means regarding sphere and hemisphere, we already discussed about this thing. Regarding hemisphere and sphere, the only dimension is its radius itself. So here straightforward the radius is not given, but indirectly the radius is given. How? The diameter is given. What is the diameter? It is 4.2 centimeter. So from 4.2 centimeter, can't you find the radius of the sphere? Definitely. How to find that one? You have to make it half. Half of the diameter is radius. So here we will write diameter is equal to 4.2 centimeter. This implies radius is equal to 2.1 centimeter. Now you have to find the volume. Volume is equal to volume of the sphere 4 by 3 pi r cube. 4 by 3 into pi into what is r? R cube. Okay, we will write the equation first. 4 by 3 into, regarding pi you can write 22 by 7 into r is 2.1 the whole cube. So 4 by 3 into 22 by 7 into 21 by 10. I am going to write this as 2.1. Instead of 2.1 we will write 21 by 10. That will be more easy. Into again 21 by 10 and again 21 by 10. Why 3 times? R cube, right? It's R cube. 3 times you have to write. 7 3s are 21. 3 and 3 will get cancelled. That's it. Anything more? Definitely you can cancel this 4 and 10 by, and here you will get 5. But actually I tell you, whenever in the denominator part if it is of zeros, keep it there. Hundreds, thousands, 10,000, keep it there. Unless and until you can completely cancel them, keep it there. So here 4 multiplied by 22 multiplied by 21 into 21 divided by here 1000. 10 into 10 is 1000. Now 4 into 22 is 88 multiplied 21 21s are 441 divided by 1000. So you have to multiply these two numbers and then you have to divide it by 38,000. When you're multiplying these two numbers, what you will get? You will get 38,808. 3 here, that much centimeter cube. Now you got the volume. Actually, you got the volume. It is 38.808 centimeter cube. You got the volume. Now, what you want to find? You want to find the mass. Actually, mass. You know that mass is equal to volume into density. What's the volume? Here it is 38.808 multiplied by density is already given in the question. It is 8.9. Multiplying them together, finally you will get the answer as 345.39 gram. That much grams. So this is the way how to find. So actually the question was to find the mass. So you have to keep in your mind mass is equal to volume into density. So density is already given. So the only thing which you have to find is the volume. So that's why we went with volume. We found the volume first, and thereafter we were coming to this position. So whenever a question comes, what is given regarding the particular question, you must know, you must be aware regarding the equation. And in the equation, what things are to be added, that thing you have to notice. Then if the given material is there, what is the unknown quantity, that you have to find it first. Then you have to substitute and you will come to the final solution. That's it. So that's the way how to deal with this one. I hope you understood. Good. Going to the next question. A hemispherical tank is made up of an iron sheet. So there is a hemispherical tank. Just imagine a hemispherical tank. It's made up of iron sheet with a thickness of 1 centimeter. The thickness of the iron sheet is given. It is 1 centimeter. So imagine that in your mind, an iron tin sheet, and we are making a hemispherical tank, something like this, something like this. A hemispherical tank you are making, and the width of the tank is given. It is 1 centimeter thickness. It is 1 centimeter thick. Then if the inner radius is 1 meter, see, the inner radius is 1 meter, thickness is 1 centimeter. So both of them are in different units. One is in meter, another one is in centimeter. So keep that in your mind. That's why I am just focusing on the units very perfectly, so that you can understand what it is given. So 1 meter is the inner radius and the thickness is 1 centimeter. Then what is given? Then find the volume of the iron used to make the hemisphere. So if you want to make such a hemispherical tank, what volume of iron is required? So you have to find the volume of iron required. Here you must not find the volume of the hemisphere actually. Why? If you are finding the volume of the hemisphere, it will become the hemisphere, means it will become the volume of the solid material. But here it is not solid because it's a tank. That means when you want to find just the volume of the tank, it means it's an open hemispherical bowl, right? It's a tank, it's a bowl, something like that. So if you want to find such a thing, actually let us draw it first of all and let's see it how it comes. So if you are imagining a hemispherical bowl, actually this is the thickness. This much is the thickness, and the inner radius is given. It is 1 meter. Inner radius means from the center point to here. This is 1 meter, and the thickness means from here to here. It is 1 centimeter. 1 centimeter. So what is given? The inner radius is given, and the outer radius is not actually given, but you can find it. How will you find? The inner radius small r is given. The inner radius small r is given 1 meter. Thickness is equal to thickness actually you cannot write it as T, you will write thickness itself, you have to write. Thickness is equal to, how much it is? It is 1 centimeter. 1 centimeter means 1 centimeter. How much meter it is? 1 centimeter means how many meters? It is 0.01 meter, isn't it? Means divided by 100. You have to divide it by 100, you will get 0.01 meter. So what about the outer radius r? It will be inner radius plus the thickness. So inner radius is 1 centimeter, it is 1 meter plus the outer radius is 0.01 meter. All together we can write 1.01 meter is the outer radius. Now in order to find the volume of such an open shell, right? It's an open shell. So here volume of the hemispherical tank. is equal to, what's the volume of the hemisphere? 2 by 3 pi r cube. So 2 by 3 pi capital R cube. You will get the total volume of the hemisphere minus 2 by 3 pi small r cube, the inner one. Together you can combine like this, 2 by 3 pi into r cube minus small r cube. That is 2 by 3 into 22 by 7 into what is r cube, capital R it is 1.01 cube minus small r is 1 cube, right? It is 1 cube, yeah. It is 1 cube. Don't think that it is 1.01 cube minus 1 cube means subtract this together then find the whole cube. No, it's not. It's a cube minus b cube. You already know the equation of a cube minus b cube. It is equal to a minus b into a square plus ab plus b square. So that much you have to deal with. It's not just easy. So first of all you have to find the square root of these two things and you have to subtract them, then you have to multiply by this given variable. Finally, for the approximation from this one you will get it as a 0.06348, that much meter cube. Actually this is an approximation, so we will write approx. That will be the volume of the hemispherical tank. So actually if you want to find simply the hemispherical tank's volume, you can simply find it, but here actually it is an open thing, means it's a tank or it's a shell, right? So at the time it's not a solid material, so that's why we had to minus them. You have to find the total volume of the hemisphere minus inner hemisphere's volume. You have to take it off, then you will get the remaining part will be the total volume of the iron material. So that's the way how to deal with this one. I hope you understood, right? That's it. One more question from this side. So next question before you, question number 3. A capsule of medicine is in the shape of a sphere of diameter 3.5 millimeter. Here again, diameter 3.5 millimeter. Diameter is given, right? Diameter 3.5 millimeter is given. And you have to find how much medicine, especially in the bracket it is written that you have to find it in millimeter cube. So that means you have to find the volume. So how much medicine is needed to fill the capsule? If you want to fill such a capsule, what amount in millimeter cube should be the total medicine? So what we have to deal with, we have to find the volume. It's very clear because it's in millimeter cube. So nothing to worry about this one. It's a very straightforward question. So one by one, let us write what is given. The first thing given is the diameter of the capsule is given. The diameter of the capsule D is equal to 3.5 millimeter. Now the diameter is given. Now tell me what's the next. From diameter every time we will come to the radius. Radius is equal to, it will be always half of this one. So 1.75 millimeter. You got the radius. Now what is the next thing? You have to find the volume, right? You have to find the volume. So what is the equation to find the volume of a sphere? V is equal to 4 by 3 pi r cube. So you have to use this equation in order to find the volume of the sphere. So here from this one, 4 by 3 pi r cube, that is equal to 4 by 3 into 22 by 7 into, here r is 1.75 the whole cube. You have to multiply them, means you have to find the cube of that one, and then multiplying them all together towards the last you will get it as 22.46 millimeter cube. So in other words we will write like this: the total amount of medicine to be filled in the capsule is 22.46 millimeter cube. Actually here there is no need to make it into liters or milliliters or something like that, because in the question very perfectly it is mentioned you have to express it in millimeter cube itself. So that's why that's the answer. So that's all. So that's all about this chapter actually. So in this chapter all together we studied plenty different typical types of shapes. Initially we studied about cuboid, and cuboid means length, breadth and height. That are the 3 dimensions which is required. Then the volume of a cuboid, length into breadth into height. Then the lateral surface area, the LSA of a cuboid, 2 into L plus B into H. The total surface area, 2 into LB plus BH plus LH. You will find the total surface area. Then we studied about a cylinder. So cylinder, regarding cylinder there are 2 dimensions, one is the radius and another is the height. And the CSA of the cylinder is 2 pi RH. Then TSA is 2 pi r into r plus h. Then the volume is pi r square h. These are the things regarding cylinder. Then we studied about cone. Regarding cone, there are again dimensions. One is the radius, another one is the height. Next one is one more thing added to that. It is the slant height L. So slant height L, radius R, and the height H. These are the three dimensions which are being used when we speak about a cone. So regarding cone, we studied about the Csa of the cone. Csa of the cone is pi RL. Then Tsa is pi R into R plus L, and the volume is base area into height. So actually here it is 1 by 3 of that of the cylinder, so 1 by 3 pi R square H. Okay, that is about cone. Then we studied about sphere. For sphere, there is no Csa and Tsa. Altogether we will say it is only a surface area. So the finding surface area, it is pi R, 4 pi R square. And finding the volume of a sphere, 4 by 3 pi R cube. Then we studied about hemisphere. Regarding hemisphere, half of the sphere. So Csa will be 2 pi R square, Tsa is 3 pi R square, and finally we studied about the volume of the hemisphere. Volume of a hemisphere is 2 by 3 pi R cube. So these are the equations which we study in this whole chapter. So if you know these equations very perfectly, actually I tell you, whenever a question comes very fast, you can deal with those things. And we studied about combinations of solids also, right? How to combine the solids, and from combining the solids, how to understand the Csa, Tsa, all these things. So this chapter is so important because when you're coming to your 10th class, there also you will study the same chapter in the new dimension, in the new version. There you will have to study. So these are the basic things which you have to keep in your mind. It's very important and very easy chapter and very important chapter as well. So I hope you understood today's session and this whole segment of surface areas and volume. Again, we will meet again in the next class with a new chapter. Till then, take care and goodbye. Have a wonderful day.